to keep the desk groups where they're at, because if we are shoving desks around, so it kind of encroaches on other team space or the door or whatever. And we just want to make sure that you can all see the board easily. So if you ever have a big issue, let us know. We can help try to fix that. I'm guessing we have some people absent today, so our group of 5, we might break that up once we give our friends a couple more minutes to get to class. Today we are on 226, and I just realized with the recorder thing counting where it is, that's never going to work. But let's try to fix that. We are going to dive right in because yesterday we did an all review of the previous lesson. We are going to look at our little intro and then dive right in. So our intro for today, I will go ahead and get us centered while we wait for any stragglers. So mathematics is a powerful tool for solving many problems we encounter in the real world. This is why I'm doing what I'm doing. But real-world math problems worth solving often involve messy, or what I often call ugly, numbers in many steps. Fortunately, the operations we know, addition, subtraction, multiplication, and division, can be applied to all the different kinds of numbers we might encounter. Today we'll review multiplication of simple fractions. Then we'll extend that to working with fractions greater than 1, mixed numbers, decimals, yada yada. As we work with our team, keep the following question in mind. Would using a different form of this number make the problem easier? We want to make your life easier, which I still think is confusing for some of you, since this is math class, and often people get this stigma that math is just hard. It's not. It's very useful. It's difficult at first, but so is riding a bike, so is dancing, so is dating somebody. Really difficult stuff at first. But then it gets easy. So let's dive into 2-95. Whether you're in your toolkit or your math journal, whichever one you're taking notes in now, everybody needs to first date our assignment for today. So it is 10-4. 10-4, good buddy. That means like Roger, or I heard you, or I got that. 10-4 is like an affirmative statement. And our topic today is 226. And we are multiplying mixed numbers. I'm going to abbreviate this. MULT, multiplying mixed, and then the hashtag for numbers. I'm going to abbreviate because I want to make my life easier. Did you already have all that written down? Okay, we're all dating and heading our notes. Then, as a group, dive into 295. Try to remember our techniques from yesterday that we talked about. If you get done with 95, move into 96. 97. This is a lesson that I think we could potentially get all the way through and have time for homework at the end. So please make sure I as we go through the year, we're in October now, right? I shouldn't need to remind you that your homework is in 2 different places. So if you came in here late, here's your homework again. Also, it's always over there. So I will at some point just stop saying anything about it, assuming that you guys have figured out that process. Does that make sense? It's October. We've been here for a couple months now. We're getting this all figured out. So we're on page 109. Go ahead and dive in. I'll give you at least 5 minutes. Awesome. So you might want your page from yesterday out. if your rectangle is wider than it is tall, and you need to split things into fifths and then into sevenths, who knows what the easier way to do this is? Split the fifths across, then split the sevenths vertically. Just because we have more space to work with vertically. So if I split my fifths across, I'm going to draw 4 lines. So you guys can obviously keep working. Those would hopefully be closer to equal space than what I had. But handy dandy smartboard. Keep working. I'm just going to call on random people to help me. Marvin, after I split my fifths, what should I do? After I split my fifths. Shade in 3. So be careful. After I split, I got to shade. Then I split and shade again. So shade in 3. So then, Kate, after I split my sevenths, or if I'm splitting into sevenths, this is a good question. How many lines am I going to draw? And if they're a little off in your drawing, it's okay. I luckily can shift a tiny bit. Kate, what do I do after I split my sevenths? I do what? If I'm doing it visually, if I'm using the rectangle, after I split, all I did was cut into 7 pieces. So all I'm communicating is divide by 7. How many of those sevenths do I want? 6. So I gotta shade 6 of these in, right? So we're gonna shade, and actually I'm probably gonna shade in orange. So 1, 2, really all but one of them. Then what section do I really care about? What am I looking for my final numerator? Grant? Yeah, the double shaded boxes, which comes out to be here, how many boxes? 18 out of my total rectangle is now broken up into 35. So, Mr. Cooper, what does the 5 times 7 actually tell us? The denominator times the denominator. Yeah, which really tells us what? I agree with that, but... yeah, the total boxes in the diagram. Not TA. And the 3 times 6. Francesca, what does the 3 times 6 tell us? Right, it gives us 18, but in the context of like our rectangle visualization, that 18 then represents not just the part that's shaded, the part that's double shaded, right? So this gets double shaded, and that's really the region that we're talking about. So the numerator, what is it called? The answer to a multiplication. Starts with a P, answer to a multiplication. Product, the numerator product tells us our double shaded. The denominator product tells us the total boxes we break it into. So on 296, try to use that faster method, not the rectangle method, but try to use that faster method from Aubrey. I know it's spelled differently. Or yeah, this is Audrey, sorry. Near IE anyways. In many ways. All right, try that for A through F. Now, I don't like doing this, but I'm curious to see what group can do this the fastest with everybody having the answers written down. So, when you get done with F, get a check from Mr. Smitheron. Yeah, eventually, but you don't have to at first. Just get us the original, then we can simplify later if we want. Make sure we're writing out the problem, not just the answer. I'm going to write out the problem, not just the answer. Make sure we're writing out the problem also, not just the answer. So write out this fraction times that fraction equals. I wish we could write in the textbook. That would make our life nice. We'll simplify eventually. Don't stress about that right now. Just get the initial multiplication. All through F, and you wrote down the problems too. You guys all have the same answers that you discussed? Liam, I said it like 4 times, and I asked, and you said we're done. I said, and the problems too. Go back, man. Nice strategies. You have your multiplication table. If you don't want to think very hard, you can just grab your multiplication table. All right, I'm going to use that group to start getting some answers up here to check what you have going at your group. So, Annika, what do you have for A? 35 over what? 48. And then stop us if you have something different. I'm just going to write down exactly what they give me. Kate, give me B. Liam, give me C. 36/49.
Good morning. Allison Brown, please come to the office. Allison Brown, please come to the office. Thank you.
Patrick, D. 12. You said 56? Yeah, let's move on. 6 what? Yeah, 20 seconds. It's weird to say. And then our last one here. Anybody or everybody. 72 over 42. Now, we can go back and reduce some of those, any that share a common factor, but it didn't ask us to reduce them. So for now, we're going to go ahead and move on, but any of these with common factors could be reducible. So things to look for, can they both be divided by 2 or both be divided by 3? It gets a little bit harder above that, but we see odd, even, so that might be a little tough. We could try 3s or 5s or something like that. Even, odd, evens, this will totally reduce, this will totally reduce, that will totally reduce. So all of these are reducible. Right, just divide by the same thing on top and bottom. So like one way we could reduce 1256. I don't want to think very hard. I just start reducing by 2. I just keep cutting in half. So we'd get 6 over 28. I can do it again. Get 3 over. Then I'm stuck. So then I'm done. So we could do that to a few of these. Move on with your group to, sorry, were there any questions from that? We all good? Straight across top, straight across bottom, use your multiplication table. Eventually, we'll use calculators if you want. Go ahead and move on to 97 then. This multiplication is how, or this like rectangle is how we make our life easier. And eventually, what we want you to be comfortable with is doing this in your head. But this process, we want to establish this using this visual breaking apart of the number. So on your paper, draw this rectangle. Then, as your team, or with your team, complete parts A through C. And try to figure out what is the area, which area we know will be product. Area is always going to be length times width. Really need to orient my smartboard. All right, so go ahead and try that multiplication using this rectangle method. I'm going to orient my smartboard. First thing I'm going to do is draw that rectangle and mimic what's there. You know a square is a rectangle. A rectangle is not necessarily a square. A square is always a rectangle. A rectangle is not always a square. Either way, draw it on your paper. Aubrey, do you need to go to conversation? What? Making life hard. Half of a half. What's up? Just that. Label it. 1 here, half there, 3 there, half there. Then we got to figure out what the products. Now be careful. That looks like you added. Because half of a half, half times a half. So we are multiplying, right? If this is a visualization and not a great one, because as my group back there wanted to argue, this kind of looks like a square. Her garden is obviously not a square. But trust what you know, not what it looks like. Trust the numbers given to you. So, Eleanor, for the section at the top left, 3 times 1, what would be the area of this section? 3. For the area, Zoe, of the top right. Yeah, how'd you get that? Yeah, and the other way around, when you multiply by 1, nothing changes, right? So, now this one's a bit tougher. Delaney, what about this plot part of the garden? How big is that? 3 halves, because it's 3 feet wide times a half tall, or whatever you want to say. It is 3 halves. And then, Emily, what about, and this is what people struggle on a tiny bit, bottom right plot. How'd you get that?
Well, when you multiply 1 half by 1 half, they have each other.
Yeah, it's half of a half. Half a foot by half a foot. A quarter. Now, all of these would have what kind of label on them? Feet squared, because it is area. So please make sure that you're aware these would all have labels of feet squared. Now wait. Now we need to write an equation that represents the sum of all 4 areas. So I wanted to make note of our label first. Try to sum all these up to find the answer. Then, could you write a multiplication not using the rectangle, Aubrey, you wouldn't have to use the rectangle then. Could you write an easier multiplication that we could solve just as, well, actually easier than this? So first add these all up, then try to write an easier problem. Make this simpler. Can we add these up fairly easily? So we have 3 halves plus another half. Right, if I look bottom left, top right. 3 halves plus another half. What do these make together? Well, this is 1 1/2. Well, yeah, 2 wholes. So if I look at 3 plus 3 halves, that's writing really thick, plus 1/2, so that's 3 halves, plus a 4th. Now I'm just going to look at all of this. 3 halves plus a half is 2, plus 3, 2 plus 3, 2 plus 3, 5, making sure we're alive. I got scared for a second. Then plus a 4th. What do we get as our total sum? 5 and 1/4 feet squared. Now, has anyone figured out how we could do this a whole lot easier? No rectangle, no anything. Aubrey, did you figure it out? Because I know you didn't want to use a rectangle. I did. Well, okay, that's fine. That's very like you're kind of just putting them in. You're saying all rectangles. You just don't like all rectangles. It's a very definitive statement. We know how to find the area of a rectangle normally, right? Length times width. But here that's tough because they're mixed. Anybody figure out the easier way to do this? Yeah, I see. Patrick?
1/2 times what? 1/2 times 3 1/2. I mean,
1/2.
1 and 1/2 times 3 1/2.
Isn't that exactly what it says? That's not very easy. I don't like mixed numbers. I can't even type those in on my calculator. I saw my buddy do it, but I don't know how.
Then make it improper.
Oh, man.
6 over 2 times.
Improper fractions are always easier to work with. I hate making blanket statements, but I'll make a blanket statement here. Mixed numbers are complicated. There's holes, there's parts, there's what. Improper makes it simpler. Now, here's the dangerous thing. I already heard 2 people say it wrong. 3 1/2 to turn into improper So let's write out 3½ times 1½ Then we're going to make it improper. To go to improper, we multiply down, then add to the top. So this becomes 7/2. This becomes 3/2. What's 7 times 3? 2 times 2?
4.
We get 21/4. Now hold on. How many 4s are there in 20? 5. How much do you have left over?
1.
Same answer. A lot of right ways to get to Florida. So if we know that that's the easier method, then solve 98. I bet you can do it in 90 seconds. Go.
I'll try. Oh, I can do that. I know. How much is it?
Get caught up with the group of whatever you can. Don't worry about this. The easy method is just straight across top, straight across the line. So we look at like this rectangle method is right here. You don't get all the notes down, it's okay. Just make sure you understand. Like especially when you get these, you just quickly practice straight across top, straight across bottom. So see me if you have any questions, but I know yours out there still. So write down the mixed numbers first. Now wait, the process shown in the previous problem doesn't need the rectangle. If you want to use it, you can, but you don't need it.
You don't need the rectangle here for this one. Doug, 30 seconds.
Stop rushing me! Oh, this is
Are you the person that talks about who dies at the end of the movie at the beginning of the movie?
Yeah.
Don't be spoilers in this class, please. When your group gets an answer, keep it to yourselves, at least somewhat quietly.
The butler did. Alright.
Now, here's another word to be careful of in math. By. What is the word by being used here? It's not like bye. Of course, it's not spelled right to even be that by, for the record. Yes, but not always. Hey, so give me your attention for just a second. By is a word that we use in math to give dimensions. Yeah, like by. So, here's the problem though. Here, by means multiplication. There might be another problem. Sorry, just waiting to not get talked over. It seems like everyone else has more interesting things to say than me. There might be another problem that says find the amount of fencing needed or perimeter or what of a garden 1.5 feet by 5 1/3. So be careful with the word by. It does not have a set definitive meaning. Okay, like we talked about of and per. Almost always of means multiply. Almost always per means divide. By, be careful. It can be used multiple ways. Here we want to multiply with it. So, Penelope, what's the first thing I'm going to do to make life easier? And Aubrey, when I turn 1.5 into improper, what do I get? 3/2. Renaud, what do I get when I turn 5 1/3 improper? Alright, so do it with me then. What's 5 times 3? 15. Add that to the 1. 16 over 3. When I multiply through Grant, my numerator becomes... Let's break it up. 3 times 10. 30. 3 times 6. 18. I think you went one more. I think you went to 21. So this is actually 48. We good?
Yeah, I wrote it all down.
Okay, and then, okay, everybody. 2 times 3?
6.
8.
18.
I got it.
I heard it twice.
18 squared.
Feet squared. Check your label. Make sure it's squared. Check your label. I'm telling you right now, on a test, you just give me the answer of 8, it's wrong. Okay, I will mark on there like label or all right, dogs, cats, pizza, but it's wrong. No naked numbers. If it doesn't have a unit, put the word unit. Okay, unless literally the problem just isn't using units at all. Some things are just numerical. But this is using units. Questions? These sort of things are important when you're trying to figure out like how much fertilizer or how much dirt or anything else where you need to know the size of your garden. All right, let's look at 99. So as Janique was working in class, she had the problem. Can we quit reacting to unique names, please? I know Janique is unique, but let's move on.
Wow.
Had the problem 2.5 times 3 1/4. She did not want to draw a rectangle. Sound familiar, Aubrey?
Yeah.
However, she thinks that she has figured out a shortcut for multiplying the numbers. We need to check her work. So I know how to change mixed numbers into fractions. That will make the problem much easier, she boasted. Now what she really means is into improper fractions. She didn't quite use the whole word there. So look at her work, check if it's right, and then let's solve these problems. I bet 3 minutes. I bet we can do this in 3 minutes. Work as a team. We're going improper first, then mixed. Or sorry, improper first, then multiply.
Don't worry, we're just talking. Well, all of you. If you hear it, we're just talking. Well, we always have to figure out how to like do teams or whatever.
By the way, always, you are welcome to tell me, like, privately, if there's somebody that you really don't want to be on a team with based off, like, a personal reason going on or whatever. That is fine for a short-term thing, but you'll probably end up on teams with every person at some point during this year. So just with how the teaming will go. Let's just do impropers first. So I'm not even looking for final answers here. Emma, can you give me the impropers that we turn A into?
7 over 2 times 3 over 2.
7 halves times 3 halves. Awesome. I don't know what's going on. Ella. Interesting combination in the deck. What about B? What's that turn into?
4 halves.
Ooh,
4
4
thirds.
thirds
Times 5 halves.
times 5 halves. Nice. And C. Matt, what do you have for C, the impropers?
4 over 3.
Uh-huh.
Times 10 thirds.
Times 10 thirds. Perfect. All right, rocking back through, getting my answers now. Alan, what's our answer for A?
Well, I got 21 over 4.
Well, that would be because that's the answer. Good work.
Well, then I
Wait,
changed
you
it
didn't
to a
even
mixed fraction, which is 5 over 4.
Nice. And we already actually had that one, so that one was kind of fortunate for us. Nathan, B. What's our answer there? So go straight across the top with me. What's 4 times 5?
40.
Then straight across the bottom.
6.
And then how many 6s fit in 20?
3.
What do we have left over?
2.
Can that be reduced?
Yeah.
The fractions both even, so we get 3 1/3. Perfect. Annika, what about C? 49. Be careful. The common mistake I'll see somewhere like this, they slip back into the addition rule, and because their denominators started the same, they keep it a 3. Always remember, we're multiplying straight through. I'm just trying to clue you into the mistakes to not make, because I've seen them in the past 5 years. So, Annika, how many 9s fit in 40? Yeah, 4. And what do we have left over? Yeah, 4 and 4 9s. Huh. So, Liam, you're actually the last card of today. Which method do you prefer here? No, quit being nice. Okay, they all work, but if we're trying to make our life as easy as possible, right? We're trying to be efficient. We're trying to save time. Time's money, right? I mean, that's what they say. Which do you think would be more efficient then? Why?
Well, because you can just do it really quick and then simplify it. Instead of doing the rest.
When we break up the numbers, like, let's go back to that garden problem for a minute. So I do a lot of construction work, like a lot of projects. I do a lot of things. If I'm working in feet, and I have a distance of 3.5 feet, right? So probably about like this long. How else could I look at my 3.5 feet to make life easier and work with simpler numbers? It's actually right here. Patrick? There's another thing I can do with American Standard units that is different. Because we did improper fractions, right? That was fine. Monica? The number what? Sure, or inches, or anything else where I can just use a straight up number. How many inches is 3.5 feet? Trying to 42, right?
Yeah.
Instead of using 3.5, I could actually combine this and say, well, really, you're 42. There are a lot of ways I can look at things to make them easier. Improper is one of those ways. Instead of breaking it up into pieces, let's just make it easier to look at. So thank you guys very much. We're all dismissing early. I don't know quite why, but we're like 2 minutes early, so whatever. Have a wonderful day, guys.